A ladder is 10 feet long, is leaning against a tree. The base of the ladder is pulled away from the tree at a rate of 5 feet per second. How fast is the top of the ladder moving down the tree when its base is 5 feet from the wall? Write your answer 2 decimal places. That was the first problem. The second problem, a ladder is 10 feet long, it is leaning against a tree. The base of the ladder is being pulled away at a rate of 5 feet per second. Consider the triangle formed by the side of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changed with the base of the ladder, and the ladder is 10 feet from the wall. Write your answer.
Action.
So a visual representation of the problem that we had outside is a right triangle. So some of the information that we already know is that the ladder was 10 feet, that x equals 5 feet, and that dx over dt equals 5 feet per second. And we're looking for dy over dt. So an equation to represent what we're looking for is x squared plus y squared equals h squared. Now we already know what h is, so we're going to plug that in. It's 10. So now the equation will be x squared plus y squared equals 10 squared. So because we're going to have to differentiate later, we're going to say x squared plus y squared equals 100. So now we're going to go ahead and find the derivatives, and it's going to be 2x dx over dt plus 2y dy over dt equals 0. So once we get to this step, we're also going to need to go ahead and start plugging in information that's going to be good to solve the problem. So to do that, first of all, we're going to have to find y. And that we're finding all on this other separate side of the problem. And to do that, we're going to go ahead and plug in the 5. And that's going to make it 5 squared plus y squared equals 10 squared. Then it's going to be 25 plus y squared equals 100. You can subtract 25 from 100, you get y squared equals 75. So y equals the square root of 75.
Action.
Okay, so now we're going to start plugging information from outside sources to help us solve this problem. So first you plug in 5 feet for x, then you plug in 5 for the dx over dt, and then it's plus 2. Then you plug in the root 75 that we just found for the y. Multiply that times dy over dt equals 0. So now you start combining terms, so you get 10 times 5 plus 2 root 75 dy over dt equals 0. And then you get 50 plus 2 root 75 dy over dt. So then you're going to go ahead and subtract the 50 from the left side. And now that you subtracted the 50, you're going to go ahead and divide by 2 root 75. And once you simplify, you get dy over dt equals negative 25 over root 75 feet per second. So now you know that the top of the ladder is moving down the wall at negative 25 over root 75 feet per second. So another great representation of that problem, problem number 2, is a right triangle. So some of the information that we already know is that that ladder is 20 feet long, which can be seen from there. We also know that x equals 10, and we know that dx over dt is 5 feet per second. So what we're looking for right now is dA over dt, or the rate at which the area is changing. So to find this, we're going to find dy over dt, which is how fast the top of the ladder is falling down the tree, and we're going to find dx over dt, which is how fast the bottom of the ladder is moving away from the tree. So because we're working with triangles, we're obviously going to know the area of the triangle, which is 1/2 base times height, or for the purposes of this problem, 1/2 x times y. But to find the rate of change in the area, we're going to need to find dy over dt, and we're going to need to use dx over dt. We're already given dx over dt, but we're going to find dy over dt over here. And to find it, we're going to use the Pythagorean theorem. It's commonly used as a squared plus b squared equals c squared. For the purposes of this problem, we're going to go x squared plus y squared equals h squared. Now we already know h, that's 20, so we're going to go ahead and plug that in. And we're going to go ahead and also square it as well. So it's going to be x squared plus y squared equals 400. So once we get to this point, we're going to go ahead and differentiate. We get 2x dx over dt plus 2y dy over dt equals 0. So right here, to go any further, we're going to need information from outside sources. We know dx over dt, we know x, but we need to find y so that we can isolate dy over dt. So to do this, we're also going to use the Pythagorean theorem, but we're going to plug in 10, the x. So you get 10 squared plus y squared equals 20 squared. That's 100 plus y squared equals 400. Subtract 100 from 400, you get y squared equals 300, and then y is the square root of 300. So now that we have this, we can be in our way to isolating dy over dt. We go ahead and plug in all our outside numbers. We get 2 times 10 times 5, which are x being 10, and the rate of change dx over dt being 5. And then we get 2 times y, which was root 300, is what we just found, is dy over dt times dy over dt equals 0. At this point, we're going to start combining terms. So we get 20 times 5 plus 2 root 300 dy over dt equals 0. We're going to go ahead and multiply 20 and 5 together to get 100 plus 2 root 300 times dy over dt equals 0. We're going to subtract 100 from the left side. And finally, we're going to divide 100 by 2 root 300. And 100 is obviously negative. And then once we simplify, we get dy over dt equals negative 50 over root 300. So now we go back to the initial equation that we had brought out before, which was a equals 1/2 x times y, the area of a triangle. So now that we have found dx over dt and dy over dt, we can use both of these to find the rate at which the area changes in this triangle. Before we do that, we're going to go ahead and differentiate. So we get dA over dt equals 1/2 dx over dt times dy over dt. Of course, we just found dy over dt, and dx over dt was given to us. Once we plug them in, we get dA over dt equals 1/2 times 5 times negative 50 over root 300. Once we multiply this out, we get dA over dt equals negative 250 over 2 root 300 square feet per second.